here's a few things I want to talk about this, and then we're going to use that same concepts to talk about how to add and subtract radicals. So what we just added and subtracted here were variables, okay? Like, so for example, how did we know to add 3x squared to x squared? What did the powers were the same and the variable was the same, right? Two things were the same. The variable, the power. They both had powers of 2, and then 9x, that's x with the power of 1, like this negative 2x, those go together. And then negative 5 and 3, they also have the same variable and power. It just happens to be x to the 0, right? Because anything to the 0 is 1. And so that's how we knew we could combine those two things. So in order to combine like terms, they had two things in common, their variable and their exponent. But when you actually did the math, you didn't do anything to the exponents, right? This is still x squared. What was the math that you did? 3 plus 1, right? So the math that you did was on the number in front. Anybody happen to remember what we call that, the number in front? Starts with a C. Coefficient. So we did the math on the coefficients, right? So we're going to do a similar thing today with radicals. So, actually, let me go back here in a couple other examples. Let's say you had, instead of 3x squared and 1x squared, let's say you had 3 cube roots of 5, okay? 3 cube roots of 5. In order to combine like terms with this, two things would have to be the same. The root and whatever's under the radical. That would be the two things you'd have to be the same here. So if I gave you these two things, top or bottom, which one is like this one? The bottom one, right? Because they have the same root and they have the same number under the radical. So if you were to combine those, here's what you would do. You'd say, I have 3 radical 5s, and I'm adding 2 radical 5s. How many radical 5s do I have altogether? 5. 3 plus 2. Cube roots of 5. Okay, and that's going to be the basic idea behind our lesson for today. I was trying to have the door open, but it's way too distracting. There's like bathrooms right there, people in the hall. Oh, you don't get distracted by them? I feel like it's distracting. Okay, so then here we go. So adding and subtracting radical expressions. Just like we could only combine like terms in the warm-up, when dealing with radical expressions, we can only combine like radicals. Okay, they have to be similar. Like radicals are radical expressions with the same root and the same radicand. Not a radicand. So that's a big, the reason why I'm introducing this vocabulary word to you, it's way better. It's easier to say radicand than to say the number under the radical, the number under the radical, the number under the radical. So in this example right here, this is just a little baby radical. Which of these numbers, 3 or 56, is the root? The 3, right? This is our work from before spring break. And the 56 is what we call the radicand. It's the number under the radical. And every time I say radicand, I also say not the radicant. In my head, I will try not to say that out loud too much. But I did just say it already in my head. So the root and the radicand. Does anybody need the screen up? You all got that down? All right, so here are some examples. In this first problem right here, 2 rad 2 minus 7 rad 2. Do they have the same root? Do they have the same radicand? The number under the radical, is it the same? Oh, yeah. Yes, right? So here's what's really going on. I have 2 radical 2's, and I'm subtracting 7 radical 2's. What kind of 5? Negative. So I have negative 5 radical 2's all together. Okay, so please notice when you're adding and subtracting, you're only doing the math on the coefficients, the number out front. The stuff under the radical, the radicand, that stays the same. Okay, when you're adding or subtracting. We'll get to that one in a second. Do this one right here. Do that second one. Raise your hand if you already have that one done. Yes? The second one right here. Okay. But that. I know. Chrislyn, what do you have for the second one? Nine what's? Right? And don't forget the 3 for the root. Yeah. So I have 5 cube roots of y plus 4 cube roots of y is 9 cube roots of y. Right? Try the third one, and I want to come around and see what you think about that, what your answers are. Try whatever you think. Trust yourself a little bit, and let's see what you got. We'll compare answers. What do you have? After the lesson. It's not very long. Here's one answer. Oh, sorry. I don't know where I got this paper from. Who else? Who has a different answer than that one? I see this answer. Who has an even different answer than these two? Anybody? What do you have? Okay. Anyone have a different answer? All right. Well, let's talk about, they can't all be right? Because they all are different. It's the bottom one, all right? So let's talk about this first problem right here. The 5 looks good, but the x and y, we didn't talk anything about how adding and subtracting means you smush the radicands together. So not that one. This next one had 5. That was close, but it's not radicand y. The radicands are different. If the radicands are different, can we add or subtract them? No. So this answer, how come this is the right answer? Because what did that person change? What did that person do? Nothing, right? Because you can't do anything. You could have also given me like an NA for not applicable, or maybe you want to write can't simplify. Anything like that that lets me know you understand you can't do it. And tell me one more time, why can't we actually simplify there? Different radicands. Very good. Right. So what's the difference between these 2 examples on the bottom and the 3 we just did? Right. There's just an extra term. There's just an extra term. So you still have to check for if the radicands are the same, if the roots are the same, but you're only doing the math on the what's. Yeah, what's outside the radical. So take a minute and write down what you think these 2 answers are. You think it's just like that? Okay, I'm writing that one. Okay. I see one answer. I see a second answer. I see a third answer. Another answer, but the same as the other third. Yeah, you just do the math on the numbers out front. All right, here's what we got. Many different answers when I was walking around the room. Let's talk about which one's right and why. Okay. You do, so like Chrislyn said, when I was passing by his desk, you do the math on the numbers out front. So let's look at that. 2 minus 6 plus 4. So order of operations, you go left to right. What is 2 minus 6? Negative 4. And what is negative 4 plus 4? 0. All right. So I have 0 square roots of 5n. Agreed? But what is 0 times anything? 0. Okay? What happens is, this will be my most common incorrect answer. Because people know that we're not left with anything, but they kind of freak out a little bit. They're like, but I still have to have the radical in the answer. No, you don't. 0 times anything is 0. This right here means how many, if this was my answer, how many 5n's would I have? 1, right? But I really have 0 of them. That's why those are different answers, okay? So now that we talked about that, you might want to need to retry that one. I'm not sure. Does anybody need time to retry this last problem? Okay. So does anybody want to volunteer their answer as tribute? Does anyone feel confident? 2 on the outside. Did anybody get something besides 2 on the outside? Around the outside? So this is really a 1, right? So when you're doing the math, it's 1 plus 5 minus 4. 6 minus 4 is 2. And so it's 2 4th roots of 3xy. All right? So all of that is something. We're going to level it up a little bit. All right? All of the radicands in these problems were already the same. What's up with these radicands? They're not the same. So we have some pre-work to do before we can even do this stuff. And the pre-work is to simplify the radicals. That means you make a factor tree and you pull out groups that are the size of the root. This is what we did before spring break. So let's start by simplifying first. Radical 20, I want to do a factor tree. How can I start that? 5 and 4? 2 and 2. You could have also started with 2 and 10, right? It doesn't matter. So then I can rewrite square root of 20 as 2 times 2 times 5. And then what about this radicand, 5? How can I factor that? That's it, right? We don't have any more math to do on that. So plus 3 rad 5. I'm looking for groups of what size to simplify out? 2. How'd you know that? I don't see a root. It's just a normal square root, right? If you don't see the root, you know it's a root 2. If there's nothing written there. So you're looking for groups of 2. So here's a pair. I'm going to pull out 1 to the front. 2 rad 5 plus 3 rad 5. 5 rad 5, right? So now they have the same radicand, and we can do the math. You try the next problem. They both have to do factor trees on the next one, okay? Okay, so here is where I did my factors. What size groups are we looking to simplify? Groups of 3. Because what root is it? 3, right? So if it's a root 3, you're looking for groups of 3. So here's a group of 3 2's. I'm going to pull 1 out front. So that leaves me 2 cube roots of 3 minus. In the second number, we have a group of 3 5's. I'm going to move 1 out front. So that's 5 cube roots of 3. Do they now have the same root and the same radicand? Yes. So we're doing the math only on the coefficients out front. What is 2 minus 5? What kind of tree? Negative all day, right? Negative 3 cube roots of 3. Please don't forget to put that 3 for the root, okay, or I'll circle it for partial credit. Now all we have is your